Think about this for a second. Every day, millions of plastic crates carry fresh vegetables, bottled drinks, industrial parts, and medical supplies across the world without anyone giving them a second glance. Yet each one survives years of crushing loads, scorching heat, freezing cold, and thousands of impacts. But here's what nobody tells you. Creating a single plastic crate demands an extraordinary journey that begins deep beneath the Earth's surface and ends inside one of the world's most advanced automated factories. Today, you're about to witness every hidden step. Imagine standing inside a factory where molten plastic glows like liquid lava, giant steel molds slam shut with thousands of tons of force, and robots move with split-second precision. The air carries a faint smell of heated polymers while powerful hydraulic machines shake the floor beneath your feet. What happens in the next few minutes transforms tiny plastic pellets into products strong enough to serve farms, supermarkets, factories, and hospitals for years. And the process begins much farther away than most people could ever imagine. Most plastic crates start their life as high-density polyethylene, better known as HDPE or polypropylene, called pages. Both materials come from crude oil and natural gas extracted in energy-rich regions like Saudi Arabia, the United States, Canada, Norway, and the United Arab Emirates, deep underground. Ancient organic matter spent millions of years transforming into the hydrocarbons that eventually become these everyday products. It's astonishing to think that the crate carrying your groceries today may have begun its journey beneath a desert thousands of kilometers away. After extraction, the crude oil travels through pipelines, rail networks, and massive ocean tankers to some of the world's largest petrochemical complexes. There, engineers separate crude oil into different fractions using enormous distillation towers that reach temperatures above 350 degrees Celsius, or 662 degrees Fahrenheit. Every barrel contains dozens of useful chemicals, but manufacturers carefully isolate naphtha, the key ingredient needed to produce the plastics used for heavy-duty crates. Most people never realize that one refinery can process more than 500,000 barrels of oil every single day. Next comes one of the most fascinating chemical transformations in modern industry. Inside giant steam crackers, naphtha mixes with superheated steam at temperatures approaching 850 degrees Celsius, or nearly 1,560 degrees Fahrenheit. In less than a second, enormous hydrocarbon molecules split apart to create ethylene and propylene gases, the essential building blocks for HDPE and polypropylene. What looks like invisible gas will soon become a product strong enough to carry over 40 kilograms, or nearly 90 pounds, again and again without breaking. The gases then enter advanced polymerization reactors, where catalysts encourage billions of tiny molecules to link together into incredibly long molecular chains. These reactions occur under carefully controlled pressures ranging from 20 to 40 bar, creating plastics that combine strength, flexibility, and chemical resistance. Manufacturers target purity levels above 99.9% because even tiny contaminants can weaken the final crate. It's chemistry operating with astonishing precision on a truly massive scale. Once the plastic forms, it cools into long strands before rotating blades chop it into thousands of tiny pellets only a few millimeters wide. These smooth pellets may look insignificant, but each one contains carefully engineered properties that determine the crate's toughness, flexibility, and resistance to sunlight. Special UV stabilizers, impact modifiers, antioxidants, and food-safe color pigments mix into the pellets before shipment. Every additive plays a critical role in extending the crate's lifespan from just a few months to well over 10 years of daily use. Those pellets now begin another incredible journey. Massive bulk containers weighing more than 1,000 kilograms or 2,200 pounds travel by freight trains, container ships, and heavy trucks across continents to molding factories. Some shipments travel over 12,000 kilometers before reaching their destination, making plastic crates part of a truly global supply chain. Yet even before production begins, manufacturers face one final challenge that most people never see. Around the world, manufacturers now blend virgin plastic with carefully recycled material collected from damaged crates and industrial waste. Advanced sorting systems remove contaminants while powerful shredders, washing tanks, and filtration units restore valuable plastic for another life. This process reduces raw material consumption, lowers carbon emissions, and keeps thousands of tons of plastic out of landfills every year. But now comes a moment where science meets engineering, and where tiny pellets transform into something surprisingly strong. What happens next inside the molding factory changes everything. As the first truckload of plastic pellets arrives, the factory suddenly comes alive. Giant vacuum systems suck thousands of tiny pellets through transparent pipes that snake across the ceiling like futuristic highways. You hear a constant rushing sound as millions of pellets race toward towering storage hoppers, while computerized sensors measure every kilogram with incredible precision. It looks almost effortless, but every second determines whether the finished crate will last for years or fail after only a few uses. Before molding begins, every pellet must be perfectly dry. Even a tiny amount of moisture can create bubbles, weak spots, or ugly surface marks. Powerful desiccant dryers heat the resin to around 80 to 110 degrees Celsius, 176 to 230 degrees Fahrenheit, for 2 to 4 hours, reducing moisture to less than 0.02%. Warm air hums through the drying chambers while digital controllers constantly adjust temperature and airflow, protecting every future crate from invisible defects. Now the dried pellets fall into the hopper of an injection molding machine that can weigh more than 50 tons. Inside, a giant rotating screw begins pulling the pellets forward while spinning at roughly 80 to 150 revolutions per minute. Electric heater bands surrounding the steel barrel gradually raise the temperature from room temperature to nearly 220 degrees Celsius for HDPE, or as high as 250 degrees Celsius, 482 degrees Fahrenheit for polypropylene. You can almost imagine thousands of tiny pellets softening, merging, and flowing together into one glowing stream of molten plastic. The screw doesn't just melt the plastic, it also mixes it with incredible force. Friction, compression, and heat combine until the molten polymer reaches the perfect consistency, similar to thick honey, but hundreds of degrees hotter. Pressure inside the barrel can climb beyond 1,500 bar, or more than 21,700 psi, ensuring every air pocket disappears. What happens next surprised even experienced engineers, because everything must occur in just a few seconds. Suddenly, the screw drives forward like a giant hydraulic piston. In less than 3 seconds, molten plastic rushes through steel nozzles and enters the mold cavity at speeds reaching 300 millimeters per second. The mold closes with an astonishing clamping force of 1,500 to 3,500 tons, preventing even the smallest leak. At this moment, liquid plastic fills every corner, every rib, and every handle of the future crate with breathtaking precision. Hidden inside the mold lies an intricate network of cooling channels carrying chilled water between 15 and 25 degrees Celsius, 59 to 77 degrees Fahrenheit. As the molten plastic touches the polished steel, it begins cooling almost instantly. Within 30 to 90 seconds, depending on the crate size and wall thickness, the plastic solidifies into a rigid structure while shrinking by just the right amount. Engineers calculate every fraction of a millimeter because even tiny changes could warp the entire crate. Then comes one of the most satisfying moments in the entire factory. The mold slowly opens, releasing a burst of warm air as polished ejector pins gently push the finished crate outward. A robotic arm immediately grabs it before it can fall, lifting away with flawless timing. The entire molding cycle often finishes in just 45 to 90 seconds, allowing a single machine to produce 40 to 80 heavy-duty crates every hour without stopping. Fresh from the mold, every crate still feels surprisingly warm to the touch. Conveyor belts quietly carry them toward trimming stations where automated cutters remove tiny excess pieces called flash. High-speed rotary blades smooth every edge in seconds, while powerful air jets blow away microscopic plastic particles. What looks like a finished product still has several important tests ahead, and that's where the real challenge begins. Before a single crate earns the right to leave the factory, it must cool to its final shape. Long conveyor systems carry the warm crates through temperature-controlled cooling zones, where powerful fans circulate filtered air at 20 to 25 degrees Celsius, 68 to 77 degrees Fahrenheit. Over the next 5 to 10 minutes, the plastic finishes crystallizing, locking in the strength that will allow it to survive years of heavy use. What looks like a simple cooling process actually determines whether the crate will stay perfectly square or slowly twist out of shape. Now comes the first inspection. High-speed laser scanners sweep across every surface, while AI-powered vision cameras capture thousands of images in just a few seconds. The system checks wall thickness, handle openings, rib geometry, and overall dimensions with an accuracy of plus or minus 0.3 millimeters. If the smallest defect appears, the computer instantly flags a crate before a human operator even notices it. But computers cannot measure everything. Experienced technicians still inspect random samples by hand, running their fingers along every edge and checking each corner for tiny imperfections. Years of experience allow them to detect subtle defects that machines occasionally overlook. It's one of those rare moments where human skill still beats even the most advanced automation. The testing becomes even more intense. Massive hydraulic compression machines slowly apply forces exceeding 5,000 kilograms, simulating years of warehouse stacking in only a few minutes. The crate creaks under enormous pressure, but its reinforced ribs distribute the load exactly as engineers designed. Watching hundreds of kilograms squeeze the plastic without causing failure feels almost unbelievable. Next comes one of the most dramatic tests in the factory. Robotic drop testing machines repeatedly release fully loaded crates from heights of 1.2 to 2 meters onto thick concrete slabs. The impact echoes through the testing hall as the crate slams into the floor again and again. If even a small crack appears, engineers immediately investigate the entire production batch to find the cause. Some crates face extreme climate testing before they ever carry a single product. Environmental chambers expose them to temperatures as low as minus 40 degrees Celsius, minus 40 degrees Fahrenheit, and as high as 70 degrees Celsius, 158 degrees Fahrenheit for many hours. Engineers also bombard them with intense ultraviolet light, recreating years of sunlight in just a few weeks. Only the toughest designs survive without fading, cracking, or becoming brittle. Once every test is complete, automated printers add permanent markings to each crate. High-speed laser engravers or inkjet systems apply company logos, recycling symbols, batch numbers, QR codes, and production dates in just a few seconds. These markings allow manufacturers to trace every crate back to the exact machine, mold, operator, and production shift that created it. Imagine scanning a simple code and uncovering the entire life story of that crate. Finally, robotic palletizing systems take over. Multi-axis robotic arms stack perfectly finished crates with incredible speed, arranging hundreds every hour onto wooden or plastic pallets. Stretch-wrapper machines tightly secure the towering stacks before autonomous forklifts transport them into massive distribution warehouses. Their incredible journey through the factory is complete, but their worldwide adventure is only just beginning. In the next section, you will discover the astonishing technology and hidden quality systems that make millions of these crates trusted across the globe. Walk into a modern plastic crate factory today, and you'll find something that feels closer to a spacecraft than a traditional manufacturing plant. Hundreds of intelligent sensors constantly monitor temperatures, pressures, motor speeds, vibration, and energy consumption every single second. If even one reading drifts outside its target range, the control system reacts instantly, often before a human operator notices anything unusual. Most people never realize that one small sensor can prevent thousands of defective crates from ever being produced. Artificial intelligence now plays a remarkable role in every production cycle. High-speed AI vision systems compare each freshly molded crate against a perfect digital model, using millions of reference points. They can detect tiny sink marks, scratches, short shots, flash, and surface blemishes in less than 1 second with accuracy beyond human eyesight. In many factories, these systems inspect more than 12,000 crates every single shift without slowing production. Industrial robots never get tired, never lose concentration, and repeat the same movement thousands of times with astonishing precision. 6-axis robotic arms remove hot crates from molds in just a few seconds before placing them onto conveyor systems with repeatability better than plus or minus 0.05 millimeters. That level of precision is thinner than a single human hair. Watching these machines move almost feels like watching a carefully choreographed industrial ballet. But here's something surprising. Even the smartest robots still rely on skilled people. Experienced mold technicians regularly polish steel mold surfaces by hand, removing microscopic scratches that no automated polishing machine can safely reach. A defect smaller than 0.01 millimeter could leave a visible mark on every crate produced afterward. Sometimes decades of human experience still outperform the most advanced technology in the building. Every production batch undergoes strict quality documentation before shipment. Many manufacturers follow internationally recognized standards such as ISO 9001 for quality management and ISO 14001 for environmental management. Food-grade crates may also comply with FDA or European Union food contact regulations, ensuring they safely transport fruits, vegetables, dairy products, and beverages. Behind every simple plastic crate stands an entire system built around trust, traceability, and consistency. Even after passing inspection, manufacturers continue collecting data from every machine around the clock. Predictive maintenance software analyzes vibration, motor temperature, hydraulic pressure, and electrical current to predict failures days or even weeks before they happen. Instead of waiting for a breakdown, technicians replace worn components during scheduled maintenance, keeping production running almost continuously. It's one of the hidden reasons modern factories achieve efficiency levels that would have seemed impossible just a generation ago. Now, let's zoom out and look at the incredible scale of this industry. Manufacturers around the world produce hundreds of millions of plastic crates every year, serving agriculture, food distribution, beverage companies, retail chains, pharmaceutical logistics, and heavy industry. Together, this global market is worth well over $10 billion annually, and demand continues to grow as reusable packaging replaces single-use materials. Imagine stacking 1 year's production end to end. It would stretch for thousands of kilometers. China leads global production by a wide margin, followed by India, the United States, Germany, and Italy. Together, these manufacturing powerhouses supply a significant share of the world's reusable plastic crates, supported by advanced molding technology and massive recycling networks. Thousands of factories employ hundreds of thousands of engineers, technicians, machine operators, logistics specialists, and maintenance workers. Every crate represents a combined effort of people spread across an extraordinary global supply chain. The story of the plastic crate began only a few decades ago, replacing heavy wooden and metal containers that absorbed moisture, splintered, rusted, and required frequent repairs. Advances in polymer science during the 1960s and 1970s completely changed the packaging industry, creating containers that were lighter, stronger, washable, and reusable for years. Today, many crates complete more than 100 transport cycles before being recycled into brand new products. But the future promises something even more remarkable. Did you know that some heavy-duty plastic crates can support over 1 metric ton when stacked correctly? Did you know that a single reusable crate can replace hundreds of disposable cardboard boxes during its lifetime? And perhaps most surprising of all, many of today's crates eventually become tomorrow's crates through advanced recycling systems that recover and reuse valuable plastic again and again. The journey doesn't end when a crate wears out. It simply begins another cycle. But before we leave the factory, there's one final lesson you'll never forget. You came here expecting to see how a simple plastic crate is made. But now you know the truth. Behind every crate stands an incredible chain of oil fields, petrochemical plants, chemical engineers, precision molds, powerful hydraulic machines, intelligent robots, and skilled workers whose experience cannot be replaced by software alone. Every stage depends on the one before it, and every tiny detail determines whether that crate will survive years of hard work. The next time you see stacks of fresh fruit in a supermarket, bottled drinks in a warehouse, or industrial parts arriving at a factory, take a closer look at the plastic crate holding them together. It quietly supports enormous weight, survives harsh weather, resists chemicals, and completes hundreds of trips across cities, countries, and even continents. Most people never notice it, yet modern supply chains would struggle to function without this remarkably engineered product. Sometimes the greatest inventions are the ones we hardly ever stop to appreciate. And this is where the story comes full circle. What began millions of years ago beneath the Earth's surface became crude oil, then advanced polymers, tiny plastic pellets, glowing molten material, and finally a product trusted by industries around the world. Through heat, pressure, chemistry, automation, and human expertise, something ordinary became extraordinary. Once you understand the journey, you'll never look at a plastic crate the same way again. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.